Good morning, everyone. My name is Shashikar and this is my team, Amarnath, Shumari, and Darshan. Our topic is smart water irrigation. Introduction. Nowadays, in farmers choose more methods, and irrigation is one of them. The land to be irrigated time to time because water, if what land gets dry, the crops will not yield. Sometimes this process needs more water. Automatic irrigation absorbs the soil moisture from the soil and it helps to water the plants whenever the water is needed. Manually it takes more human resources. With the IoT project, we can reduce the human resources. The combination of existing methods and IoT project with the wireless sensors, we can develop agricultural methods more efficiently. Concept of IoT, and from IoT, the data is generated, and with the data, we analyze the sensor moisture of the soil, and it helps to water automatically. The main aim of this project is to monitor the agriculture land from the without any location or direction barriers. We can control it from any part of the world without any human interaction.
Now the irrigation system is the conventional irrigation where the farmers are going to on the motor from the lake. The motor is situated near the lake, so we can operate the motor from home itself. Because limitations of this existing system are presence of farmer all the time in the field is must. Location barrier is control motors. Remote access is not possible. Water get wasted where the more water get into the field. When the more water is going to feed the crops may lost its yield. And the proposed system is the advantages. Farmers will monitor the moisture level from the home itself, and we will notify that soil moisture sensor will send the notification to the phone itself. Since it is based on IoT, the farmer could control the motor from the place where he can. It does support remote access. Water could be used effectively as it monitored by sensors and uploaded for farmers' notice. From this, yield can be expected to the farmers. Now the designs and architecture of the diagram will explain by HTML.
Architecture diagram. In this data acquisition, soil moisture will sense the data and transfer to the controller, and it sent to the wireless data transmission and plus database, and it will process the data processing and decision making, and automatic irrigation will be apparatus used in this project is ESP32 soil moisture sensor, water pump, relay.
So now we see the feature enhancement. The project can be improved further by implementing the following details. It can be improved further by adding more sensor like humidity sensor or temperature sensor, and the data read from the soil could be analyzed using machine learning. Moving to the conclusion, the proposed application is aimed to help farmer monitor and control the irrigation irrespective of his location. To achieve this, we have used ESP32 microcontroller, moisture sensor, and web server and Android application. So the system developed at the field further fetches the soil moisture content using moisture sensor and uploads to the host server. Server using ESP32 kit. All these details are accessible to farmer via Android app. He has the privilege to turn on or off the motor using the buttons provided in the Android application. So I hope this application serves to save water and manage the crops efficiently. Thank you.
This is the soil moisture sensor which checks the humidity. Sensor which sensor.
ಕುತ್ಕೊಂಡ್ಬಿಟ್ರೆ ಬೆಸ್ಟ್ ಅನ್ಸುತ್ತೆ ಪಾಸ್ ಮಾಡು.
This is the soil moisture sensor which senses the moisture of the soil, which sends the data to the processor. The processor takes the data and analyze and it send to the information to the user. And if user wants to water the plants, he'll on the switch button and this data will come again to the processor and it starts the motor. And water is
Before watering this,
When the soil is dry, the notification appears in the email or a message like it will notify me like that the land is dry. As the motor is turned on, the water pumps to the agricultural field.